contact on one side specifically. So it's going to destroy the tool by being off center. So never ever do you want to hold it in a drill chuck because of that, and for the fact that this isn't grabbing very well in that diameter at all. And you start putting some side pressure on this, it's not meant to hold that thing square and true. It's going to flex and it's going to give somewhat in comparison to this collet. So if that tool flexes and gives, you're not holding it accurately against the material. It's going to bounce all over, and again, you're going to destroy the tool. And you're probably going to destroy the drill chuck too, because this tool is not meant to hold on to it like that. It's meant for Z-axis thrust. It means all the pressure comes directly right up into it, and that's it. So even if it's off a little bit, you know, for a drill, which drilling isn't an accurate process, it's really just a roughing process. It's not meant for basically taking any pressure sideways on it. You're going to destroy things, and it's going to destroy your cutter, the tool, your part, all the things are going to get destroyed. So we're not going to use an end mill in there. So hopefully we get that. Okay, so going back here then, we're going to load the drill chuck in, and we're going to load our edge finder into this. So my drill chuck on this machine needs to actually go into a 3/4 inch diameter collet. Some of the other machines have a drill chuck mounted on an R8 sleeve that's just all connected. So in our scenario, we just have a straight sleeve, so we have to slide it into there. But some of the mills are different. Both work just as good as the other. So we're gonna take that 3/4 inch collet, slide it up in there, and our drill chuck. So you can notice the drill chuck protrudes a little bit more. We're gonna end up dropping that table. Right now I'm gonna lock this. There we go. And we are going to use our edge finder. So our edge finder is a magical tool. Drop this down and I'll give you a visual on it. All right, so this edge finder has a unique end here. It's got a spring that goes all the way through the middle of it, pulling tension on it, and this thing can shuffle back and forth on that. What's critical about this is that the diameter of the tip of this measures 200 thousandths exactly. I could measure it, and I'm just going to use a caliper, but you'll see that it is exactly 200 thousandths in size. So that is important because we're going to make an adjustment after we make contact with this to actually get us to the true center. So I'm using this drill chuck, and I don't have to clamp down super hard on this. I'm not putting any pressure really on it. It's just a tool just to initiate a location. So usually when spinning your edge finder, you're going to spin this about 1,000 RPM. Everybody has their own little thing. Some people say, oh, I go 1,500, I go 2,000. I would never go any more than 2,000. I usually go about somewhere between 750 and 1,000, and that seems to work really good and consistent. So firing this up, turn the spindle on. This would be one unique tool that really wouldn't matter if you were going clockwise or counterclockwise because you're not cutting with it. It's just a tool to spin and an orientation. So I'm going to take the RPMs right now and turn those down to 1,000. That's my magic number. Move over our X or Y axis here and our X axis. And what I want to have happen here is I want to have the tool come down about 200-300 thousandths lower than the part is. So from the front orientation, it's going to look like that. And then what I'm going to do is I hit this with my finger and knock it off center. I want that thing wobbling quite a bit. Now what I do is I take my X-axis and I slowly jog this into it. And it's going to make that more and more true as it makes contact. So it's coming now and it's starting to touch the side of it. You'll see it's truing up. And I'm going very slowly here on the X-axis to make it true up more and more. And what I'm looking for is it to go perfectly true, and then it will kick. And it's going to kick off, should kick to the right side. Right there. So right there it kicked off, and that is my magical point where I've met the edge of the part. So what I do right now is go X and 0, because I just established the X axis. Now, if you'll notice, it is off. The center of the spindle is not on that edge where I truly want it. It is actually the radius of the tip of that off right now. So that means what I need to do is move over 100 thousandths to compensate for that. So I'm gonna lift my Z, and remember the diameter of this tip was 200 thousandths. So I'm gonna lift that Z up, and I'm gonna, at 0 right now in X, I'm gonna move it in exactly 100 thousandths. Again, not 10 thousandths, but 100, so 0.1. And I want that to be right on. Now I am truly on the center of that edge of that part with the spindle. So at this point, again, I go X and 0. And now that axis is found. Then I will do the same thing on the Y-axis on our origin corner. Notice our red mark here should be back here on this corner, which it is. So go over here, bring that down a little bit below the face. You definitely want to be a couple 100 thousandths down before the face, below the face. I've done it before where I try to do it at like 10 thousandths or so. And when I started to edge find it, it actually crept up and that thing popped up over the top of the part by accident because it was spinning and boom, blew into pieces. So you'll break the spring on there if it comes up and grabs on the top of here just because of the rotation of the tool. So go at least, I would say at least 100 thousandths below there, if not 200. And we're gonna come in, we're gonna make contact with the Y-axis. Now last time we were over here, we made contact in this direction, we saw the thing kick to the right. Here, we're gonna come to the front of it and we're gonna look directly at it, and it's gonna do the same thing. So it's gonna get a little truer and truer as we make contact. There, it gets better, and we're going really slowly here with our Y-axis hand wheel. And there it kicked. So at the point that it kicks is when it counts. You don't stop before that. You want to see it kick off. From here, we're going to go up, and we're setting the Y-axis right now. So we're going to go Y and 0. And our X is still relevant to where we were previously. Now I'm going to lift the Z-axis up, and we're going to move it. It's actually the negative direction in Y. So I'll bring this. Oh, this thing's actually backwards. It's supposed to be negative. So we're going to bring it to Y of 100. And that puts us right on this edge this way. So one last time, I'm gonna go Y and 0. Now if I were to bring the machine to true X0 and Y0 with the DRO, this is where you, oh, here we go. All right, so X is perfectly centered, and Y is perfectly centered. So the center of the spindle right now resides right on the tip of that corner, our origin corner. So what's beautiful about this is now we don't have to worry about anything compensating for anything. We go to the exact numbers that our blueprint specifies, and that's where we're gonna put our holes in at. And that's what we're trying to do right now. At any point, you don't want to unclamp this. If you unclamp this and move that part, you've lost your orientation. You're gonna have to go through and re-edge find to find that 0. So for now, stop the spindle, and we're gonna lift up a little bit there. I think I'm gonna drop this knee a little farther. And what's beautiful is the DRO is gonna remember where we are, so even if I accidentally bump this or whatever, it still knows that 0 is 0, so we're set. Now I'm going to take out our edge finder, and the edge finders are located on each one of the machines. They just kind of hang out right here on the setup, or